Okay, so what I'm going to do here is show you how to find the equation of a tangent line using implicit differentiation. Alright, so up here we have the equation y squared minus 2x is equal to xy, and we are going to find two equations for tangent lines. I'm going to find an equation for a line tangent at the point positive 1, positive 2, and then I'm going to find the equation for a line tangent at the point negative 8, negative 4. Okay, so the first thing we want to do is we're going to take our equation and we are going to find the derivative of this with respect to x. Okay, that means we are looking for dy dx. Alright, and so actually what we're doing is we're doing dx on both sides first. Alright, so we're going to find the derivative with respect to x of y squared minus 2x, and then we're going to find the derivative with respect to x of the other side of the equation, which is xy. Okay, alright, so to find the derivative with respect to x of y squared, we're going to take the derivative of y squared, which is going to be 2y, and then there's not an x here, so using the chain rule, we're going to have dy dx. Now we're going to take the derivative of 2x, and this is with respect to x, and the derivative of 2x is going to be negative 2. Alright, over here we're going to have to use the chain rule, so we'll have the first thing, which is x. The derivative of y with respect to x is going to be 1 times dy dx, plus, and then we'll have the second thing, which is y, and then we're going to multiply that by the derivative of x with respect to x, and that's just going to be 1. Alright, so we'll clean this up a little bit. We've got 2y dy dx minus 2, and over here we've got x dy dx plus y. Alright, now we're solving for the derivative of y with respect to x. That's what we're trying to do. So we're going to get all those on one side. I'm going to subtract this over here. And in the same step, I'm going to add that 2 because it has no dy dx on it over here. And that's going to give me 2y dy dx minus x dy dx, and this is going to be equal to y plus 2. Okay, now again we're solving for the dy dx, so let's factor it out. So we'll factor out a dy dx, and we're left with 2y minus x over here on the left, and then nothing happens to the y plus 2 over there on the right. And then since we're solving for dy dx, we'll just divide by the parentheses there, the 2y minus x. Alright, so the derivative dy dx is going to be equal to y plus 2 divided by 2y minus x. This is going to be y prime, y'all. Okay, so now we have the derivative. Now we want to find the equation of the tangent line at for this particular equation. Okay, well, we've got a point, we have a derivative. We figured out earlier that the way to find the slope of that tangent line was to substitute the coordinates of my point into my derivative. Well, I have y's and I have x's. Well, guess what? Over here in my point, I have an x and I have a y. So when I go to find the slope, I'm going to use my y here, which is 2, and I'm going to add the 2 that was already there. And then in the denominator, I'm going to take the 2 that was already here and multiply it by y, which I know is equal to 2. And then I'm going to subtract x, which we know is equal to 1. And then we're going to simplify this. This is going to give me 4 divided by 4 minus 1. That's 4/3. So that means that at the point positive 1, positive 2, the slope of the tangent line is 4/3. And now if I want to find the equation for the tangent line, I'm going to use my point-slope form, which is y minus y1 is equal to m times x minus x1. Alright, and y we already know, we said that was 2. The slope we just found to be 4/3. And then x1 we know is 1. And then I'm just going to clean this up a little bit so that it's in y equals mx plus b form. So we have y minus 2 is equal to 4/3 times x minus 4/3. And then solving for y means I have to add that 2 to the other side. And we will get y is equal to 4/3 times x plus 2/3. And this is the equation of the tangent line at the point positive 1, positive 2. And now if I want to find the equation for the tangent line of -8, -4, I'm going to do everything all over again, starting right here with the slope. Alright, so change colors here. Now my slope, let's see, we're supposed to do y. Well, the y coordinate's -4, so we'll have -4 plus the 2 that was already here. And then in the denominator, we'll have the 2 that was already there times the -4, which was my y coordinate, minus x. So minus the x coordinate, which is -8. Alright, so these two negatives are going to make a positive. In the numerator, we're going to have -2. In the denominator, I have -8 plus 8. That gives me 0. This slope is actually undefined. Okay, now what this does for me is it tells me I don't have to go through my point-slope form this time because an undefined slope only happens on vertical lines. Okay, so when we have undefined slope, this is vertical lines only. And vertical lines all have the same equation. They are x equals and then it would be whatever the x coordinate of my point is. So in this case, we have -8, -4. The x coordinate is -8. Therefore, the tangent line is x is equal to -8. And if we took a look at this on Desmos, you could see the original equation and you could see both of those tangent lines. Okay, so here we are over in Desmos. And the equation, remember, it was y squared minus 2x is equal to xy. Okay, and here is actually a picture of our original equation, y squared minus 2x is equal to xy. Now the 2 points where we want to find the equation of that tangent line, we wanted one at +1, +2, and we also wanted one at -8 and -4. Oops. Try that again. There we go. Alright, so you see we've got the +1, +2 over here. This is a point on my curve, and the -8, -4 right here. This is a point on my curve. Alright, the first tangent line we have is y is equal to 4/3 times x plus 2/3. And you see it drew this nice pretty black line right here that is in fact tangent to my red curve. And then my other one was, we've got x plus 0y equal to, what was it, -8. And then it's drawn me this nice pretty straight line right here that is tangent to my curve. Okay, so this is just to check your work and make sure that you have done everything correctly, but the actual process that you need to follow is in fact right over here. So we're going to find the derivative first, okay? Then find the slope by plugging in the x and y coordinates into the derivative, which we did, and then use your slope intercept equation, or you can use your point slope equation to try and find the equation for your tangent line there, and then you're going to have it. And that's all there is to it.